speech online is growing to be an increasingly hot issue, but what is the best way to address it? Hate speech on social media in particular is drawing a lot of negative attention, and it can have undeniable effects. Hate speech on Facebook in particular led to the mass migration of 700,000 Rohingya Muslims who had to flee persecution and violence in Myanmar. Facebook's guidelines explicitly state that they will not allow attacks on what they call protected characteristics. These include race, gender, religion, country of origin, and sexual orientation. YouTube's policies bans attacks on these same issues. Twitter has no explicit hate speech policy and will only take down specific calls to violence against other people. Currently, Facebook, YouTube, and Twitter all use reactive methods for dealing with content that qualifies as hate speech under their guidelines. This means that a user can post content that qualifies as hate speech, and another user will have to see that post, recognize it as hate speech, and take it upon themselves to report it. After it is reported, an employee working for the social media company can review it and decide if it qualifies as hate speech and needs to be removed. This method is ineffective, and that a viewer has to be already exposed to hate speech to report it. Social media companies also seem to be pretty slow when it comes to reviewing reported posts. In 2016, Facebook, YouTube, and Twitter signed a code of conduct with the European Commission, promising to remove content that qualifies as hate speech 24 hours after it has been reported. They were found to be successful at completing this task only 40% of the time. And since then, not much has changed about the reporting system, other than hiring more people to review reports. An alternate method that could serve to replace the system of reporting and reviewing is automatic flagging. In an ideal system, after a user has created a post, if that post potentially qualifies as hate speech, the intended recipient could receive a notification, rather than having to view the content of the post. The notification could tell the user who had created the post what type of hate speech may be present in the post, and present the user with the option to look at the post or to choose not to look at the post. Stephanie Ullman compares this quarantining method to how spam emails are dealt with in people's inboxes. They are screened, placed in a separate folder if found to contain spam, and deleted after 30 days. The quantity of research looking into how to detect hate speech is growing, and machine learning is becoming an increasingly popular method to attempt to deal with the issue. One of the problems that computer systems have run into in the past is using a binary system to identify hate speech. This means that they will try to sort online text into the hate speech category or the non-hate speech category. Some studies have focused on qualifying something as anti-Semitic or not anti-Semitic, and others focused on calling things abusive or clean. This binary system is proved faulty because computers often use profanity to identify hate speech. However, most online content containing profanity is not hate speech. So any profane content is more likely to be sorted improperly. Shervin Malmazi, a Harvard research fellow, and Marco Sampieri, an RIT professor of computational linguistics, have worked to mitigate this problem by having a computer classify pieces of text using a three-pronged system that includes hate speech, offensive language but no hate speech, and no offensive content. Malmazi and Zampieri have also created a confusion matrix to illustrate that computers struggle to differentiate between offensive language and hate speech. The AI systems used by Malmazi and Zampieri learn by reading 14,500 tweets that have been categorized as abusive or not abusive. These tweets help the AI learn what patterns to look for and what qualifies as an abusive tweet and what is not abusive. The AI can look for word patterns called n-grams. N-grams are a natural language processing concept that is defined to be a sequence of n words. A bigram is two specific words next to each other, a trigram is 3, a fourgram is 4, and so on. Malmazi and Zampieri found that fourgrams worked best for the purpose of detecting hate speech, and that increasing the n value after this point did not improve the computer's detection ability. Machine learning and computer systems are growing more effective for online text. However, they have a difficult time classifying pictures. There are a lot of subtle meanings that can go along with pictures that a computer might have a hard time identifying. For instance, this is sexist. This is also pretty sexist, but it's bad this time. Using an AI to detect hate speech before random social media users have to be exposed to it could be a good step forward for social media sites like Facebook, YouTube, and Twitter. There are still many improvements that need to be made in computer detection before it can be used to quarantine posts, but this process could give us a safer internet.